All right. Hi, everybody. Happy Thursday. Thank you for coming. Um, a lot of reminders today. Just things that as I'm preparing, I'm like, oh wait, I should tell them this. Um, so one of the things that I think a lot of you have had issues with is if you type scanner, but it doesn't show up as an import. One of the things that fixes it for me is if I clean the language server workspace, that basically just does a reset of Java in the window that you're in. Um, so I can do that by Command Shift P on Mac. If you're on Windows, it's Control Shift P. And then if you type Java clean, and then this is going to show up. So you do that, and then you click reload and delete, and it basically just does a reset, restarts Java, and then usually that fixes it. So if things aren't working, that's one thing to try. You'll have to probably wait for it to load a little bit. The other thing is if you are editing and you fix something, but you still get the same error, make sure that the file is saved. If you do Command S or Control S to save the file, then sometimes it lights up pretty colors. I think the reason is that when you save the file, the VS Code will go ahead and recompile it for you. The other thing to note is that if you have a 0 on an assignment, don't panic, but also that means that there's something that I need from you. So if I put in a 0, that just means I don't have it usually. And so make sure to submit it as soon as possible, and then I'll regrade it and you won't have a 0 anymore. Okay. I actually want to talk about this after homework 1. So, okay, homework 1 and lab 3 are technically assigned, depending on how much time we have today in class. I'm hoping to use the time to work on lab 3. So homework 1, let's zoom in here. Homework 1 is assigned. It's going to use topics that we are practicing in class today and going forward. But you could start today. So homework 1, let me find it. There we go. Okay. So this should be on Canvas. So we go back to, nope, that's the wrong. Zoom back out. Assignments. Homework assignment number 1. Okay. That shouldn't be Eclipse. That should be VS Code. Okay, so the prompt for homework 1 of what you're actually doing, it's in this Word document, which is this one. And for homework 1, there's 2 problems. So for lab, the lab is more guided of do this small activity. Homework 1 is a bigger project, and there's 2 problems. Let's go through problem 2 first, because that's the easier one. So problem 2 asks you to create this class called binary array. So let's let me see, can I draw on here? Okay. So we're used to arrays with integers, right? Where the things in the array are just numbers. A binary array is, instead of numbers being there, it's true or false, and so on. So the things in the array are Booleans. And so your job is to create a class called binary array that handles this and does stuff. So there's a lot of, so I have like the options. I think I want to have us get a little bit more familiar with like fields and methods before we get too in depth about it. But just so that you're aware that it exists, I would like you to go home and read through this assignment. And if the words don't make sense, that's okay. We're going to talk about them, just so that you get like a first pass at what you're being asked to do. The other problem is the fun one. So I guess we're maybe close enough to Halloween that it could actually be the Halloween heist. But if you're familiar with the TV show Brooklyn Nine-Nine, if not, that's okay. Have a link here. I think I need to share the sound for it to work on Zoom. Share sound. Oh no. Wait, hold on. Why? No. Zoom audio device. This also may not work. Oh, okay. That's loud now. So
it's heist time. You get a head start on heist prep? Good luck.
So yeah, so the whole idea with Halloween Heist is it's these characters and they, to celebrate Halloween, they get together and decide, okay, we're gonna go and steal this sentimental item from one of the other characters. And it's fun, it's silly. And so your job is to create a text-based game that does something like that. So it doesn't have to be Brooklyn Nine-Nine, it can be whatever your favorite media is. You're going to create code to actually make this game. But I can tell you kind of what mine looks like. Let's see. It's over here. Okay. So for mine, there's departmental training and so the characters are rotating through different workshops. And first I have to choose who my characters are. So if I do 5 and 6, Terry and Rosa, and then I have some text of here's what's happening in the workshop. And then I have the goal is for the characters to steal the instructor's clicker. And so you can try and steal it or you can not try and steal it. So if I just try and steal it every time, and then either they succeed or they fail. And so if they fail, then the instructor will take away a clicker if your team has it. And so I'm having terrible luck today. Keep getting caught. And so, and then at the end, I print, here's how many clickers I have, here's how many clickers the other people have. So yeah, so you're gonna make something like this. It's not gonna be exactly like it. You make it fun is my instruction to you. So the thing you can do today is you can come up with a script. So like how I've got this script of here's the situation, here's the characters, here's what you print in each round. You can write that just like in a Word document. And that's something that I want you to submit. So you can get started on the creative part, even if the code is still we're a work in progress. Okay, so that's homework 1 to start. We'll go over it again. And hopefully we'll work on lab 3 today. For lab 3, something that you'll need to know for homework 1 is in homework 1, you're having different methods that access the system.in scanner. So you'll have one method, maybe do something and get input, and then you pass it to another method. And you may have some issues with that. A way to get around that is if you define your scanner as a field in your class, like we've got here where we have the system.in, this is a final static field. Because one of the issues that can happen is if you open system.in scanner in one method and then close it, and then try and open it in another method and then close it, it does not like that. So yeah, I would recommend doing something like this as you start to work on homework 1. The other thing is I fixed the IO files. So if we go to the home page and then the lectures page. So this one, so for each day, I have the files that we look at in class. And so I have the non-confusing versions here that you can like download and run. So let me open those in this one. Okay, so file IO test. So I've separated each of the tasks into methods. So for read 35 lines, that's just what we had originally. So we set up while file in has a next line and we haven't gotten to 35 yet, then just print it. I have a method to print the line numbers. And so this prints the line numbers, doesn't save it to a file. But the only thing we changed is we print count and the colon. To write the line numbers to a file, we open the print writer. So we've got file out. And instead of printing to system.out, we print to file out instead. And so that's those are the file IO ones. There's also the Magna Carta. Where to print the first 50 lines, the only thing we changed was the limit to count. So we increased from 35 up to 50. To print the first 4 words, this is a little bit different from what we did in class. So we still have the while loop, and I get the next line and I have a scanner that goes through it. And then I'll say I have a for loop to go from 0 to 3. And then if there's something next, then add this next word to the string that I'm printing. To print only the first line of the section, it took me a little while to kind of figure it out. So we do have if the first character of the line starts with a parentheses. But then I realized that it prints not only that, but also lines that start with like a word that's in parentheses. And so to get around that, the simplest way I could think of is to say if this thing that was in parentheses contains a number, then print that line. It's not going to be foolproof. Like maybe there's a typo where there's like a word and a number, and in that case, maybe it's not. But for this, I think it works okay. So if we do that, that's the one I have selected to run. And so for that, it prints the first 50 lines. So you can download this code on Canvas, play around with it, make sure it works on your computer. The other thing that I want to note is that these two files are commented. And so you'll see there's like good documentation for each method to say, here's what this method does. I have comments on here's why I need this thing. And so the idea with code that you submit for the homework is I would like to be commented like this is. So basically that involves comments before methods explaining here's what this method does. And then like a line comment or something before any non-intuitive thing that you're doing. So like I had to say, this is why I do line.length greater than 0. The reason I have this whole long if statement is I'm checking if there's a number in there. And so this is what I would like your code for the homework to look like. And that's good programming practice to get into, of explaining why you're doing what you're doing, which not only helps me as I grade you, but also helps you if you ever go back to this code of like, hey, I remember I did this thing in this one class and I wanted to see if I could bring it to this other problem. And it really helps when you're going back to code if it's commented and clear of this is what's going on, because otherwise you're just going to stare at it and be sad. I have done that and it's not fun. So commenting, thumbs up. Okay, so that's those two. I'll get to packages later. All right, so let's get going. So last time we talked about object-oriented programming. I don't know if Zoom sees. What does Zoom see? No, they do not see. Nope, now you see that. Use slideshow. Okay, there we go. Okay, so we looked at the 4 properties of object-oriented programming. Those are encapsulation, abstraction, inheritance, and polymorphism. We won't go over them in detail again. We're going to start by looking at the simplest possible class that we can make. So let me your slideshow. Okay, so we're going to make a class called intCell, and it's going to be a super simple class. We're only going to have one field, and that field is going to be called stored value. The idea of this is a class that will store an integer. So this is going to be an int, and we're going to have a method called read, and we're going to have a method called write. So that's where we're going. We're making this class called intCell. It's going to have this stored value as a field, and then it's going to have a method called read, a method called write. So let's make a new class, and I'll call it int cell, capital I, capital C. And we're going to have a field. And the field is going to be private. So we don't want anything outside the class to be able to modify the stored value directly. We just want everything to access it through our methods. So we want this field to be private. And the other two things are this value is going to be an integer, and we're calling it stored value. So for our methods we want to be public because that's what we want other people to be able to edit and access. So public to read the stored value, we're going to return an int. So it's just return stored value. And then to write, we're going to need to take as a parameter some integer, because this is when the user is overwriting the stored value. And so we're going to say, if I can type the right letters, stored value equals I. Pretty simple, right? We have this stored value variable, and then we've got two methods, read and write. I used to have an intCell test. I don't know if I have it anymore. So yeah, so this is our very simple class. If we want to make a demo, I'll call it intCell demo. And in here, I'll make a main method. And I can say intCell I equals new intCell. And I don't know, I'll give it 8. Nope. Okay, yeah, so the other thing, I have not defined a constructor yet. So I can't put like, here's the number that I want the stored value to be at this point. So I would have to use I.write and give it 8. And then if I want to print it, I can say I.read. Okay, so if I do this, then because I.read just returns the stored value, then it should just print what? 8, right? There we go, 8. Amazing. Okay. Java.comments. So those are the style of comments that you see in like in the Magna Carta, where we have /**. Those are different than just /* comments. So if you have like a method like this and you start typing /**, then sometimes if you've got a parameter in the method, it'll show up as here's the file name. And so the idea here is it makes it easy to publish. And so a lot of the Java implementation is documented with these Java comments. And that allows when we go to let's say I want to go to Oracle, let's say Java object. The things in here, those are all defined in the code somewhere with Java comments. So they're very useful for programmers if you're working with an application. It makes it easy to go through and see, here's what I'm actually working with. And so the other thing is, we hover over it. You can see that when I hover over this method, which I wrote, no one else wrote it for me, it prints, here's the method signature, and then it has this text that says, here's what it does. And I wrote that text. And so when we hover over it in VS Code, we can write what shows up here. So we can write that documentation ourselves. So that's Java.comments. And again, that's /** and not just, so the multi-line comment is /*. All right, so in terms of the basic class methods, we've got constructors, which aren't technically methods, but the other really common type is setters and getters. So we're going to look at two classes that really show all of these things. And before we do that, so constructors, we've talked about them a little bit. Constructors allow us to actually define objects, to instantiate them, to take them from this abstract, like lines of code, to an actual object that we can manipulate and do things with. And so the constructors allow us to set up the fields in the class. So if we don't have a constructor, then the fields, so like int cell, we don't have a constructor. So when we say new int cell, it initializes it for us. And so it'll initialize it to 0 if it's a primitive, or null if it's a reference variable. So it'll do that automatically. If we want anything else to happen, then we need a constructor. When we do that, it's got to be the same as the class name. So we'll see that in a bit. There's no return type because it's not technically a method. And we can also have multiple constructors. So let's see what that looks like. So I'm going to make a class. I want to make classes to model seminar courses and professors. So we've got seminar courses, and then we've got professors who teach those courses.
I got a question.
Yeah.
You were a student here back in the day, right?
Yes.
Did you like seminar when you were a student?
Yes, I gained a better appreciation for it after I left St. Mary's. Yeah, like it's like a book club, and everyone reads the same book, and then you go and talk. Yes. Yeah. The professor can make or break the seminar class, for sure. Okay. So we're going to start with making the professor class. Okay, and so we could put a whole bunch of things here. I'm just going to have 3 fields. And my fields are going to be all private. So I'm going to have the professor's name. I'm going to have what department they're from. And then I'm going to have the number of what class they're taking. So I think it's like 150, 250, 350, or 327. Right? I pulled up the link because also seminar has changed since I was here 6 years ago. So I think you only have to take 3 courses now instead of 4 when I was here. So
Early they changed. Yeah.
I think it's still in process.
Yeah. it's
Yeah.
For the current juniors.
Right. Yeah. Yeah. So depending on where you are, maybe you also still have to take 4. But going by the current catalog, we've got 150, 250, 327, and 350. So that's what's gonna go here. And so that's what that integer is for. Okay. So first we need constructors. So a constructor looks like we've got a visibility modifier. Generally, you want constructors to be public because you want something outside this Java file to be able to create a type professor. And it needs to match the name of the class. If it doesn't, you're going to get an error. And we do not want void here. That's a no. So a constructor is not a method. And so it's just public class name. Okay. So for professor, I want let's say I want string, let's call it N, string D for department, and then int C for course ID. So these are all parameters that I'm taking in when I am creating the professor object. And so what I do in the constructor is I'm just setting up, here's what the fields look like when I create this object. And so it's really simple. I just say name is equal to N, department is equal to D, and some course ID is equal to C. If I did not have this constructor, the string would be initialized to null. So both name and department would be null, and some course ID would be 0 if I didn't have this constructor. Now that I do have this constructor, now I can make sure that, okay, this data is assigned to these variables. Okay, let's try java.comment. So if I do /* and then enter, so that now I can say this is constructor number 1, and I'm getting it from input. And it takes all the fields as parameters. So that's my constructor. In the next class that we work on, we're gonna do more than one. But for now, for the professors, we're just gonna do one. Okay, the other really common type of methods that we need for classes. Yeah, question. The other kind of methods that we need for classes are setters and getters. So setters and getters are just things that we have to read and write the information stored in the fields. So because the fields are private, we can't access the information directly. So let me come up with a demo file so that we can see this. Okay, so first, let's say that these are not private. So let's see, how do we do that? So if for me, I did Option Shift and then click, Option Shift click, and then I can just like select all of those at once. That's useful if like you've got a bunch of things and you want to just like edit in a vertical line. Okay, how do I get back there? Okay, so for now, let's say that they're not private. Then I can go and I can create a Professor P is new professor. And then let's just go with, this is a new, have a new class to demonstrate things. So in here, we can directly access like p.department. Okay. So I could print like p.department and it prints null. If the department was named CS, then it prints CS. Generally, we don't want this behavior. We don't want to be able to access the fields directly like this with variable name dot field name. We don't want this. So that's why we make these private. So to get the whole vertical cursor, for me, it's Option Shift and then clicking. For Windows, it's probably Alt Shift. But yeah, so so we want the fields to be private, and instead we want the user to be able to access them through setters and getters. So now I could type all of those methods out, or I can have VS Code do them for me. So if I'm right-click on my code here, and then I go to source action, then this list pops up of there's all these different things I can do. So right-click on your code, and then go to source action. And then like I can generate getters and setters. That's the one that I want, because I want both of them. I could generate only getters or only setters. Yeah, question.
First, that's when you have to change them from private to public first. So
To do what?
for the summer demo files.
Yeah. So in order to do like p.department or p.name, and that's accessing the fields directly. And so that only works if the fields are not private, but we do want them to be private. Yeah, question.
So because for some reason demo doesn't recognize the class type. I don't know, is there something?
Are you sure that it's named correctly?
Yes. Yes.
Okay, let me get to that in a little bit. Okay, so once I've selected generate getters and setters, in my case, I want getters and setters for all of these. So I can just click the box up here to select all of them. If I only wanted them for some of them, then I would only, like if I only wanted it for department, then I could only select that one. But I want all of them. Then I press OK. And now I have method for get name, set department, set department, get sem course ID, set sem course ID. Question. Yeah. Okay, right click on the code. There's a source action thing. Yeah.
Like having like all of those, I don't have like it's like less, and I don't have the getters and setters one.
Are you in the professor.java file? Yeah, should be in, so be in professors.java or professor.java. Any other issues with this? Right click source action, generate getters and setters. Yes. Yeah, and so it does all this code for you. You'll notice that there's something interesting here. So like to set the course ID, it takes in an int called semCourse ID. That just so happens to be the same name as our field. And so the way that we distinguish between this parameter that is given to us and our field, the field belonging to professor, is with the this keyword. So this means this actual object. So that belongs to the field for this professor object. Okay. So those are our setters and getters. There's other things that we're going to want. One of the things that's really useful is, so let's say, okay, so now back in seminar demo, this line doesn't work because I get an error saying the field professor dot department is not visible, which makes sense. That's what we want. So instead of p dot department, I could say p dot get department. And if I run that, then it still prints CS. So instead of accessing the field directly, we use a getter method and it does the same thing. The other thing to note, what if we print P? So P is our professor object. What do you think happens if we print it? Show of hands, who thinks it's going to give us something that looks normal? Who thinks it's going to give us something that looks not normal? Okay. What did it give us?
That's the location in the memory.
Exactly. Yeah, so when we print something, it gives us, so this is actually called the hash code. But it takes something like its location in memory, which is this number over here, and then this is the name of the class. So that's something that Java defines, that if we don't have a critical method implemented, then this is what it prints. Basically the name of the class, and here's kind of roughly how it is stored in memory. If we want to do something other than that, we can use a method called toString. So I'm going to do source action again. So right click, source action, and then it's generate toString. So if we do generate toString, then it gives me some options of what fields do I want to include in this. It selects all of them automatically. I'm just going to go with that. And then I click OK. And now it has given me a method called toString, and it has this big long string. So let's see what it looks like when we test it. Did everybody get to the toString? Okay. So now it still prints professor, and now it prints something like an array where it says name equals null, department equals CS, course ID equals 0. So it prints something that's like better than just a bunch of numbers. We can change what it looks like. So instead of printing it with the brackets and stuff, we can say professor, and we can print, here's the name, and we can print from department, and then print the department, and they are teaching SEM. And then the course ID. So we can change what this string says. We can also change the fields that show up. We can change anything we want to in this string. It does need to be named toString, lowercase t, capital S. If it's not named this, then the thing we're about to do isn't going to work. Yeah. Yeah, okay. Let me come back and see what's going on there.
Really, because when I create a new class. Yeah, this is the top one.
Yeah, that's probably it. Yeah, okay, let's talk about packages for a second. Yeah. Okay, so command shift N. In class. Where are you in yeah. Okay, let's talk about packages for a second. Packages in Java are folders. Oh, yeah.
Oh, yeah, I think I'd like to copy everything exactly, but I'm getting a bunch of errors and red lines and then a lot of different things. And I really don't know what.
No, dude, I just saw it and I did it straight up. Bro, this is
Okay, we've got stuff to do. Stuff to do. Okay, let's talk about packages. Packages are folders. That's the basic thing. Packages are folders. Let's say I want, so in my like solution to these, I have them in, so here's what I recommend. For your packages, no spaces.
I didn't know what package was. I just created a new class and it has packages.
Because you created the new class into this folder.
So I shouldn't be doing that?
Well, you should.
Oh, like I got the folder name?
Yeah, so like I'm going to, let's make like an IO package. It's just a new folder in VS Code. And I'm going to move file IO test 2, and Magna Carta. Get that out of the way. And I'm going to move it to my IO package.
Folder?
Yes,
Like when you run it, it looks for everything in the package?
yes.
If I rename the package with no spaces, do I have to redo all the classes?
So if you see, so I want to go move these classes into a package. And then the pop-up comes of Red Hat wants to make refactoring changes with this move. Yes, I want that to happen because then it will update. If I open file AO test 2 now and go all the way up, now it's in package IO. So if you click OK, like to the refactoring pop-up, then that's what we want.
So I should just make a new folder and move them all in there.
Sure. Okay. All right, so where were we? And I gotta save all these guys now. Okay, so now when I print professor, now it prints something more like readable in my opinion. So instead of printing professor in the array, name equals null, now it prints, this is the professor's name from departments, CS, teaching seminar 0. So I can add a space there to make sure that it looks nice. And then if I run it again, now there's a space there. Okay. Let's make a new class. So now, so I've done, wait, no, wrong thing. Command Shift P, new Java file class, and the class name is going to now be seminar. So we're not entirely done with professor yet, but we're gonna do some things in seminar and then we'll get back to it. Okay. So for a seminar, again, there's a lot of things. We could have like a list of students, the list of readings, but to keep it simple for us, we're going to have the type of seminar. And so my idea here is, I don't know, we can have 150, 250, 327, or 350. So just like the professor's seminar course ID, we can have a string representing here's today's reading. And I'm gonna link the professor to my seminar class. So each seminar class has a professor, and so we're gonna have a field to represent them. Okay, so those are my fields. Again, we could add a lot more, but this will do for now. Now we've got to make constructors. We could type it all automatically, but VS Code also has options. So if we right click and go to source action, one of the options is generate constructors. And so let's see. Let's do which ones do I have? Okay, the ones that I have are, let's say I want the type and the professor. So let me get this out of the way. So if I select only the type and professor fields, then it gives me this. If I'd selected all three, then there would be a string today's reading in here as well. That's fine if you have that. So this assumes that we're given the type of seminar and we're given the professor. So if we just do this, and maybe let's add the toString just so we can see how we're doing as we go. We'll change what this looks like later. So I've got toString for my seminar class. And if I'm down here and I say seminar equals new seminar, got to give it a variable name. And then we said that we want the type, which let's say is 150, and we'll give it our like the dummy variable professor E. And then let's print what all of those fields are.
So in seminar demo, we're initializing a new seminar using the professor that we also initialized
Correct.
in seminar demo.
Yes. Yeah, so we've got our professor object and we've got our seminar object. And so we create the seminar object with help from the professor. And so you can see that when we initialize only the type and the professor, so it prints the type is 150. Today's reading, since we didn't set that in the constructor, it got initialized to null. So if we want something other than null, we have to specify. And then the professor is, and then it prints professor toString. So maybe we want to change how that works. Because there is some differing information here. You can fix it by saying 150 up here. But okay. So if I don't want today's reading to be null, then I have to say that in the constructor. So I can say this dot today's reading is equal to, and maybe I want to say not yet assigned. The alternatives are to do nothing and just leave it at null, or I could maybe set it equal to an empty string. So like there is no today's reading. Or maybe it makes sense to say today's reading is not yet assigned. Okay. So that's one type of constructor. I also want a 0 parameter constructor. So I'm going to create a, okay, so there's a few ways to get this. One of which is I go back to source action and I do generate constructors and I select none of them. If I do that, then it just gives me like this empty block of code. That's one option. Another option, VS Code has a snippet where you can say, I think it's CTOR. And if you do that, then it gives you something with super in there. We'll talk about what super means later. I don't need it for now. If you have it in there, that's fine. If you leave it there, that's okay too. But let's say, so we want our 0 parameter constructor. I'm going to move this comment down here where it really matters. And so here's where we set up any information. So like, let's see what prints if we just have, if we give it no arguments. So S0 is a seminar with no arguments at all. It's calling the 0 parameter constructor. Let's see what it does. So what does it do? So it initializes the type as 0, and today's reading and professor are both null, because today's reading and professor are both reference variables. And if we don't have any constructor behavior defined, it'll automatically initialize those to null. So let's fix that. So let's say, maybe we do want the type to initially be 0 if we're not specifying, here's what kind of seminar it is. Let's set today's reading to be not yet assigned. And I think I do like having the professor be null. I think that makes sense for when we don't have a professor yet. Okay. The other type of constructor we're going to need is what we call a copy constructor. And that's useful for if we have one object and we want to create like a carbon copy of another object, like a separate object, but that has all the same data, all the same fields. And so as our parameter for this constructor, we take in a seminar object. And we say type is equal to s dot get type, which we do not have yet, so we should probably do that first. But the idea is we're taking the attribute that S has and we're copying it over to this object. So, okay, so in order to do that, we need getters and setters. So let me click out and then do source action, generate getters and setters for my seminar class. And I want the getters and setters for all of them. And just the default implementation is fine. All right, give me a thumbs up when you've got the getters and setters. Okay. All right, so now we can go back to our copy constructor. So we can say s dot, our type is S's type. Our today's reading is S's today's reading. And our professor is now S's professor. So because the get prof, get today's reading, get type, those are all methods that belong to a seminar object. And since S is a seminar object, we can access those. Okay, so let's, okay, I'm gonna make a, there it is. I'm gonna change the seminar demo and give us some actual data to work with. So let's say Professor Roscoe is a new professor. And my department is math and computer science. And let's say I'm teaching seminar 150. So I'm choosing professors from the math and computer science department. Does anyone have a favorite seminar professor? No one's taken a good seminar.
Yeah, I'll go with the answer.
Brother Thomas. Let's guess TRS. Okay, so what have we got? 150, 250, 327. And then we need one more professor. Someone give me a name, please. Say that again?
Fuck what? W-A-D.
Okay,
There's an extra T in the middle.
that, okay. I do not know who this professor is. What department are they from?
Yes, I know.
Data science. Okay, and let's have them teach 350. Okay, so okay, I'm gonna comment out all my ones with P. Because now I've got actual professors to work with. Okay. We good with the professors? Cool. Now let's make classes for them. So let's say S1 for seminar 1. And so in this example, I'm supposedly teaching seminar 1. So I'm giving the constructor the variable representing me as a professor. For seminar 2, I'll give it Professor Dost. Oh, wait, no, sorry, I've changed this. So instead of 1, it's actually 150. Instead of 2, it's 250. I had it different in my notes. Let's call it ST for transfers. And that's the one that Brother Thomas is teaching. So that's 327. And then we've got seminar 3, which is 350. And there we go. Okay, so we've got our professors set up and we've got our seminar classes set up. So let's print seminar 1 and see what happens. Actually, let's set today's reading. Let me choose the ones who walk away from home loss. What?
Someone, Gregor, you know Gregor? After?
Oh, yeah, the metamorphosis.
Yeah. From you were,
Oh,
you're still thinking 7? You're 4. 4, wow.
yeah, I remember that one. Okay, so if we set today's reading, then when we run this, we should have, so I think this is the one. So type is 150, today's reading is the ones who walk away from Omelas, Professor Me, and there's additional information there. And so the reason that, when we say professor equals this whole text, that's because we're calling the toString from the professor object. So if we go back into seminar, we go down to toString. Notice that we're just printing prof, right? And the prof info is from here. So this information is what actually gets printed when we call to print the prof variable. So if we want to change and make it not as verbose as that. Let's see. Hold on, my files are mixed up. Let me find it. Where did it go? Okay, seminar page 4. Seminar page 2 and 1. Where's seminar page 3? No. I honestly have no idea where this page went. Okay, we're making it up as we go along. Actually, no.
Question.
Yeah, question. Preferably not. Because you're learning how to write Java.
Honestly, like, what if I use like AI to comment my code?
I mean, maybe. But it also depends, because like, you have to explain what it is that you're doing. And the AI may not know what you're trying to do.
Obviously.
Yeah, or just like a blah explanation. Okay. I honestly have no idea where that code went, but I do want it. So let me find it over here. Okay. All right, so I have get prof. Let's say I want another method just to return, like, here's the professor's name. Or wait, no, I don't need that. I don't need a whole new method to do that. Sorry. What do I need to just print the professor's name? Get name? Yeah. Professor's got a method called get name. Professor knows how to return its own name. So we can just go down to get name, hit enter. There we go. So now if we run, not this one, but this one. Nope. Oh. Oh yeah. Okay, so this may be some issue that we may have to fix later. So the issue right now, we get an error because, so first of all, this one prints fine. So it just prints my name. But if we try and print this seminar that doesn't have a professor initialized, then it, yeah, maybe. Or we set up something in the constructor, in the 0 parameter constructor. So instead of null, maybe professor,
You want to be initializing stuff as null if you don't have it, or is that like issues when you try to call it and something happens? Or would it be better just to initialize them as like doing stuff?
it depends. Yeah, it really depends. Okay, new professor, what did my constructor look like for a professor? I had to give it name, department, and course ID. So if I give it NA, and 0, then I should be okay. So now in my 0 parameter constructor for seminar, I've said, here's what this quote unquote empty professor looks like. So now if I run this, now we get like the professor's name is NA. Today's reading is not yet assigned and the type is 0. So now we've avoided those errors. Hooray. Okay. Questions so far?
For homework, using units though with like characters and stuff like that, right?
Kind of. Yes. That's part of it. Yeah. That's part of it for the game. So like for me, I have a so like in Brooklyn Nine-Nine, there's members of the squad. And so I have like, here's a squad member and here's their name. And I can actually show you. So so yeah, for the squad member, I have, here's their name. Honestly, okay, this is why you should comment your code because I do not remember what key means in the code that I wrote several years ago. But I have like the visibility level. The visibility level is, okay, so key is for like which character it is. For visibility level, I have like, here's how obvious they are when they're going to steal a clicker. And so
Well, why didn't you do like this level equals 20?
maybe, but you see they're not always equal. Yeah. The other thing that I had a lot of fun with is let's look at a team. So for each team in the homework, I have like here's a list of the and so each thing in the list is the character. And I also have a Boolean for the vulture. If you've never seen Brooklyn Nine-Nine, there's a character called the vulture who like swoops in and solves the cases and gets all the credit. And so if a team has the vulture on it, they automatically win the clicker every single time. And so I have a Boolean field in my team class to say, does this team have the vulture? And then I can, somewhere in the logic, let's see, I think maybe it's in player. Yeah, so I have some check to see, does this team have the vulture? And then if they do, then automatic success. So yeah, so maybe I have, would you want to do the homework in partners?
Wait, no, you guys should do this for good point.
No.
Maybe it's like a much better project. We all work at collaboratively. It's in the industry when you look at the
I mean, yes, but then the problem is someone decides like, hey, we're working on with like this media as the example, and one person's like, I don't know anything about that. Or someone is like, I really hate that. So I think maybe partners. Maybe. Okay, let me think about this and I'll send out an announcement sometime. But is there anyone who would be opposed to working in partners? If you are secretly opposed, send me an email. And you could work on it individually, but I think with partners would make it a lot easier. Okay, back to seminar. All right, so we've gone through a lot of this so far. We've talked about constructors. We've talked about setters and getters. The other name that we call setters and getters is mutators and accessors. So think about like if you're trying to access something, you're just getting it. If you're trying to mutate something, you're trying to change it. So that's a setter. Those are used to change fields and can be accessed by something outside of the class. So if we have code outside of the class, then we can access it. Yeah, we've talked about this. We don't have time for the combo lock today. Let's go through the rest of these things, and then we'll talk about combo lock next time. So we've looked at toString. This lets us print the state of the object. We entirely define what goes here ourselves. So we can just use like the standard print that that VS Code gives us when it generates this code, or we can make it say something completely different. So yeah, so what gets printed is up to us. If you're not happy with what's printed, we can change it. Okay, the other thing to know is equals. And I was testing this last night, and this is another reason that I'm not a huge fan of VS Code, but we're here, so we're gonna do it. Okay, so go back to professor. I'm gonna scroll down to the bottom, and I'm gonna do right click, source action, and then I'm gonna generate hashCode and equals. And all the strings is fine. And hit OK. It's gonna generate a whole lot of code. So the thing that was printing before we defined toString was the hashCode. And so if we look up java.object and we look at the hashCode method, so java.object, this is the implementation that is default if we don't say override this toString method. So it returns a hashCode value for the object. It's gotta say something. There was some. Is that it? No. I don't remember where it says where hashCode is defined. But you can see that for toString. So for the toString method, that's just default, it prints the class name and then the @ character and then the hashCode in hex. So that's where it comes from. Okay, where were we? We were at equals. And so this is VS's code way of generating the hashCode. And so basically it takes some prime number and multiplies it by this.
The hash is like different based on what you're using to run Java. You said this is the VS Code.
Yeah, so if you're working in Eclipse, this method may look different. This method may look different, but the result, the idea of the result is the same. The way that it gets calculated may be different. But yeah, so it multiplies the prime number with 1 plus, and then it converts the name to a hashCode. It converts the department to a hashCode. So it takes that string and then hashes it, and only if the name or the department is not null. Basically, it gives you a number that's unique for this object based on the name and the department. So let's test that. So let's go down here and let's print Roscoe.hashCode. And let's also print Professor DOS dot hashCode. Okay. So if we do that, then these two objects gave us different numbers. So the hash codes for these are not identical. If we had, let's say we did, let's say we copied the Roscoe professor object. Do we have a copy constructor? No, we don't. Okay. We have a copy constructor for seminar. So let's do the seminar to hashCode and equals. That's just the same process. Right click, source action, generate hashCode and equals. So now we've got it for seminar as well. And so for seminar, I'm going to copy my seminar. So seminar S1 copy is equal to new seminar, and it's a copy of S1. So now if I print S1.hashCode, and if I print S1 copy.hashCode, are they going to be the same? Who votes for the same once you're all done typing?
Good question, how it's sent.
One vote for the same. Who votes for not the same? Oh yeah, question.
Important or like the source
Action.
code equals.
Yeah.
It imported and like when it ran through the code, I got a redundant test statement. Is that normal for it to have faulty code?
No. Okay, so the other thing is I really do not like the way the VS Code does equals. Like, I am very much not a fan. I'm gonna show you the way that I did equals when I was in Eclipse, if I can find it. So the other thing is we also, if we have hash code, so okay, I'm getting ahead of myself. Okay. So this should work now. So, okay, who votes for same hash code for S1 and S1 copy? One vote for the same. Who votes for different? Okay, let's see. They're the same. No, they're the same. And it makes sense because we can look at how hash code is implemented. And this is basically a integer representation of this object where we've hashed today's reading and we've hashed the professor. And if it's the same professor and the same reading and the same number, then it should be the same. It should be the same. So, all that to say, we don't actually need, I don't think we actually need both of them. It like is doing things a little bit redundantly, which I'm not a fan of VS Code for. But let's kind of walk through what all of this code means. So remember that this keyword is used to refer to our current object. So our current object, that's what this is referring to. So if we're working with S1 and we're given S1 dot equals S1 copy. This is S1. The OBJ is S1 copy. That's not us. And so it's asking, are we this? So the example would be if we called like S1 dot equals S1. If we did that, then it'd be this. And so that would be true. And then like obviously S1 is equal to S1, they're the same object. The other check is if the object is null. So if this is null, we're not null. So the answer is false. These two are not equal to each other. The third option is if the classes are different. So like if we're a seminar and we were given a professor, then obviously a seminar is not equal to a professor. So these two objects are not equal. Then we get into checking the actual fields. So once we've gone through all of this, we're reasonably sure that the object is a seminar and it's not null. And so then we have to cast it to seminar. And that's, remember, Java limits implicit typecasting. So that's what the parentheses are for. To say, yeah, we're okay, at this point, we're sure that this is a seminar, so let's treat it like a seminar and go through it. And now we're checking, are the fields the same? So is our type equal to the other object's type? Is, if today's reading is null, is the other reading null? Otherwise, does our reading equal their reading? And then similarly for the professor, but I feel like you could just condense this so much. And so the alternative way to equals is, okay, so the easy way is if you have the hash code, which we do now, we could just return this dot hash code equals b dot hash code. And if they're the same, then great. If not, then it's not equals. So that's one option. The other option, if we don't have hash code implemented, we can say, we can check all that, like, are the instances the same? So if we do that with an if statement and we say if b instance of seminar, and we negate that whole thing. And so that says if b is not an instance of seminar, that means b is not a seminar object. And so we can say for sure that if b is not a seminar object, then b is definitely not equal to this object. So then we still do have to cast it because we're given an object. And so we have to cast b to actually a seminar object. And then here's where we, like, the easier way to as opposed to all of these nested if statements, we can say return this dot prof is equal to b2 dot prof, and this dot type is equal to b2 dot type, and this dot today's reading is equal to b2 dot today's reading. And so that's just a long logical and statement to say, are the fields identical? Which I think feels a lot better and like makes more sense in my brain than using VS Code's automatically generated equals. So when you're typing your own code, you can make a decision of, do I want this automatically generated code that does what I want it to, but maybe looks a little bit weird? Or do I want to have a simpler method? Because we can also just like we were given the equals method, we could delete it and put whatever code we want in there ourselves. We're the coders here. We can make these decisions. Okay. Okay, so we can, yeah, so that's my little tangent on equals. So that's one of the reasons why I think I like Eclipse better. But alas. So instance of is an operator that tests if another object is an instance of a class. So like if B is actually a seminar object. Yeah, and so that lets us make sure that we're not comparing two different types of objects, and that's going to throw us an error. So basically, and the process for all of those is check if the object is the same type as your object, and then check if the fields are the same. We've talked about this. I don't think I'm going to talk about final transfer, but it's used to self-reference an object. It's used to refer to the current object. And we'll see an example in combo lock next time, where we can use this to call another constructor. How much time do we have left? 30 seconds. The main method is, you may have noticed this, if you don't have a main method in your code, when you click run, nothing's going to happen, right? So when you have a main method, then you can click run and something happens. It's the only thing that's going to execute automatically. So the question is, so we've worked with mains before. The question is, do we want one in our class? So like, would we want one in seminar? Would we want a main in professor? We're out of time, so I'll leave you with that question. Over the weekend, okay, first of all, active learning. I'll have you submit the seminar class. Let me see, 9/12, that's today. So for active learning, submit seminar.java. And over the weekend, please work on lab 3. Work in pairs and partners, please. The homework one is going to be due a week later. Yeah, so the lab is going to be due on Tuesday. And I'll write up partner things, and let's assume lab 1 or homework 1 is partners. So you can find your partner and start working on it. But I'll communicate more information. All right. Thank you. See you on Tuesday.